Welcome to EDU World Space.
Good day. The topic is about gas laws. At constant temperature, Boyle's law states that pressure and volume are inversely proportional. So we write P times V equals sum A, where A is constant. At constant pressure, Charles' law states that temperature and volume are directly proportional. So we write V over T is equal to C, where C here is some constant. Now, let us try to establish the relationship between pressure and temperature using Boyle's law and Charles' law. From Boyle's law equation, we can rewrite P as A over V. And from Charles' law equation, we can rewrite V as C over T. Plug in V in P equals A over V. That gives us P equals A over, where your V is C over T. So again, C and A here are constants. We can rewrite this as A T over C, where that's A over C times T. Rewriting, so we have P over T equals A over C, but A over C, or a constant divided by another constant, is also some constant. This means P over T is equal to K. And just like Charles' law, so we find similarities that here with the Charles' law equation. So we also say that volume, or rather pressure, is directly proportional to temperature for the PT relationship. This means that when the ratio of P and T is constant, so for any combination of P and T, so say P1 T1, that's the same as P2 over T2, P3 over T3, and so on. So this is now what is termed as the Amonton's law. So let us use this equation for a certain problem. So we are given with gas at a certain pressure of 32.0 pounds per inch squared, or in simplest term, that's 32 psi. And then we are given that this is the pressure, particularly in the gas in the car tire, at a pressure of 75 degrees Fahrenheit. Now, we always note that temperature that must be expressed in absolute scale. So we convert this to Rankine, which is an absolute scale, by adding 460 to 75. So that's 75 plus 460, and that gives us 535 Rankine. So note that Rankine, just like Kelvin, is an absolute scale for, or absolute unit for temperature. So next, we wish to find the pressure when the temperature rises to 100 degrees or 120 degrees Fahrenheit. So that means T2 is 120 degrees Fahrenheit, or that's 580 Rankine. So using the Amonton's law we have established above, P1 over T1 equals P2 over T2. So substituting gives 535 P2 over 580. And cross multiplying to solve for P2, we get 32 times 580 over 535, or that's equal to 34.7. So as we see, the temperature rises from 75 to 120. We also see that the pressure rises from 32 to 34.7. So I hope this helps.